Good afternoon, students. Myself, Dr. Amit Vikram Patnaik. I will take you some mathematics classes, that is relations. So, what is the relation? In a day-to-day life, we come across various type of relations. So, the relations are, some of the relations are student of, some examples of relation are student of, less than, equal to, etc. So, these are some of various types of relations we come across day to day life. So, when you say student of, so there must be something between before and after. Say Ram is a student of class 10th. So, what is the relation between Ram and class 10? The relation is student of. So, another example is less than. Say 5 is less than 15, 18, 19. So, the relation between 5, 15, 18 and 19 is less than. And subsequently equal to, say x is equal to y. So, the relation between x and y is equal to. So, when you say the relation, it may be one object with one object or one object with more than one object. So, if it is one object is related to one object is called binary relation. Otherwise, it is not a binary relation. So, if we say this is example 1, example 2, example 3. So, out of these 3 examples, example 1 and example 3 are binary relations. But the second example is not a binary relations, but example 2 is not a binary relations. So, binary relation is a relation of one object with one object. So, Ram and class 10, 1 with 1, then it is called a binary relation. X and y, 1 with 1, that is called equal to, it is a binary relations. But example 2 is not a binary relations. And if we split this, 5 is less than 15, 1 with 1, then it is called a binary relations. So, in mathematics, we concentrate on binary relations. So, we can take with the example of sets. Suppose we consider 2 sets x and y and they are non-empty sets. Say 2 non-empty sets x and y, and elements say x is 1, 2, 3, y set is 3, 4. Say 1, 2 and it is 3, 4. Now, we define what is a Cartesian product. between x and y is defined as x cross y is equal to the 1 3 1 4, then it is 2 3 2 4. So, these are called ordered pairs. So, pairs means 2, ordered means we cannot interchange it, because ordered means 1 3 is not equal to 3 1. So, that is why it is called ordered. Pair means 2. So, first of all we define a Cartesian product x cross y. So, a relation between x and y. We define relation between x and y. Suppose R is a relation, R1 is a relation between x and y. So, R1 we say x y such that x plus y is equal to 5, where x belongs to x set and y belongs to y set. So, now out of these elements the R1 is 1 4 and 2 3. Similarly, we can take another example, the relation between x and y. Suppose R2 x y such that x is greater than y, where x is the element of x set and y is the element of y set. So, out of these elements none of these is less greater than y. So, obviously, R2 is equal to 5, that is called an empty relation. So, if we define a binary relations between two sets x and y, so a binary relations between x and y is a subset of all relations R between x set and y set are subsets of x cross y. So, all the relations are subsets of x cross y. All the binary relations are subsets of x cross y. So, suppose we have x set having 3 elements and y set having 2 elements. So, then x cross y has total 6 elements. We take an example, say x set has is 1 2 3, y set is 3 4, then x cross y has 6 elements. So, what are the 6 elements? So, obviously, x cross y is equal to 1 3, 1 4, 2 3, 2 4, 3 3 and 3 4. So, this is all the elements of x cross y. Now, if we define a relation between x and y, all the relations are subsets of x cross y. So, R is a subset of x cross y. So, we can take R 1 is say any relation say x is equal to y. So, out of these elements, first element is equal to second element. So, obviously, it is equal to 3 3. Say R 2 is another example, that is x plus y is equal to 5. Then out of these elements, this is 1 4 and 2 3. So, these are two elements. So, you can have another example, that is x minus y is equal to 1. So, obviously, out of this difference x minus y is equal to 1, none of these are satisfied. So, this is phi and it is called empty relations. So, we can have list out all the relations and these are subsets of x cross y. So, what is the total number of subsets? X cross y is equal to 2 to the power cardinality of x cross y. So, this is the total number of subsets of x cross y is equal to 2 to the power x cross y cardinality. So, that means the total number of relations so the total number of relations from x set to y set is equal to 2 to the power x cross y cardinality. And out of this, the largest relation is x cross y. It is the largest relations. We call it as a universal relation. And the smallest relation is phi, is called empty relation. And out of this, all these relations are in between these universal and empty relations. Suppose we can take one more example, say x set is equal to a b c, y set is equal to c d. So, what is the total number of non-empty relations? From x set to y set is equal to 2 to the power x cross y cardinality minus 1. So, which is equal to 2 to the power 6 minus 1, that is equal to 64 minus 1, that is equal to 63. So, this is the total number of relations from x to y. So, non-empty means out of this one is empty relations. So, these are all binary relations. Binary means one object with one object. Now, we will represent the diagrammatic representation of relations. Next, we will discuss, that is so how we represent pictorially a relations. Suppose X set having element 1, 2, 3 and Y set is equal to 3, 4. Then what will be X cross Y, that is equal to 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. So, these are the total number of elements of X cross Y. Now, we can represent a set by a circle. So, X set and Y set. X set has element 1, 2, 3 and Y set has element 3, 4. Suppose we find a relations R1 which is say X minus Y modulus is equal to 1. So, that means the difference between X and Y, the modulus is 1. So, out of this element 2 minus 3 modulus is equal to 1, 3 minus 4 modulus is equal to 1. So, these are the two elements. So, that is obviously 2 3 and 3 4. So, we can represent like this 2 3 and 3 4. So, this is a relations R 1. Similarly, R 2 is a relations, that is say X plus Y is equal to 6. So, out of this element 2 plus 4 this is and 3 3. So, the elements are 2 4 3 3. So, again we represent like this X set and Y set 1 2 3 3 4. So, this is 2 4 3 3. So, these are diagrammatic representation of relations. So, etc. we can represent a relations like this. Now, the elements of X sets are called domain and range. Next, we define domain and range of a relations. Domain and range of a relation. If R is a relation between X and Y, then domain of R are subset or equal to X set and range of R is subset or equal to Y set. So, we can take the same example previous. So, what is the domain of R 1? So, obviously, domain of R 1 is those elements which are related with Y. So, out of these elements domain of R 1 is 2 3 and range of R 1 is equal to 3 4. So, the same case is also, that is domain of R 2 is again 2 3 and range of R 2 is 3 4 also. So, domain is a subset of X set and range is a subset of Y set. So, we have domain and range. Next, we have inverse relations. Is defined as if R is a relation between x set and y set, then R inverse is inverse relation between y and x. So, inverse relation is just to reverse the relations. Say x set has element a b and y set is c d e. Suppose R is a relations that is equal to a c a e b d. So, we can pictorially represent by x set and y set. X set has element a b and y set is c d e. So, the relation is a c a e b d R is a relation from x to y. Then what is the inverse relations? R inverse is simply reverse this order, that is A C is C A, A E is E A, B D is D B. So, obviously, R is not equal to R inverse because these are ordered pairs. So, the inverse relation is from y to x. If R is a relation from x to y, then inverse relation is from y to x. Now, in case of domain and range, so obviously, the domain of R is equal to range of R inverse, and range of R is equal to domain of R inverse. So, what are this domain and range? So, obviously, domain of R is equal to A B and range of R is equal to C D E. So, domain of R is equal to range of R inverse. So, these are all domain, range and inverse relations. Next will come what are the types of relations. So, we have initially we have two types of relations. One is called universal relation, second one is empty relation. Besides these two universal and empty relations, the third one is one relation. One many relation, many one relation, many relation. So, broadly we have 6 type of relations. So, what is universal relation? Suppose R is a relation between x and y set. then R is a subset of X cross Y. So, if when R is equal to X cross Y, it is called universal relation. If R is equal to X cross Y, it is called universal. When R is equal to 5, it is called empty relation. So, these are two obvious cases, that is, the largest relation is called universal relation and the smallest relation is called empty relations. Now, regarding these 4 relations, 1-1 relations. So, what is 1 relations? Obviously, if one object has related to one object, it is called 1-1 relations. And 1-many relations, if one object has relation with more than one object, it is called 1-many relations. Next, many-one relations, if more than one object are related to one object, it is called many-one relations. And finally, the many-many relations, if more objects are related to more objects, it is called many-many relations. So, we can take one example. Suppose X set has element 1, 2, 3 and Y set has element 3, 4. So, what will be X cross Y? That is 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. So, these are the total elements of X cross Y. Now, we diagrammatically represent some of these relations by say X set, Y set, 1, 2, 3, 3, 4. Say the relation is 1, 2, 3, 2, 4, that is R1. Here 2 is related to 3, distinct element is distinct related. So, R1 is 1-1 relation. Take another example, X set, Y set, 1, 2, 3, 3, 4. So, one object with more than one element, it is called 1-many relation. Similarly, suppose X set, Y set, 1, 2, 3, 3, 4, 1, 3, 2, 3, 3, 1. This is called many-one relation. So, here many element is related to one element, it is called many one relation. Although it is one relation, but it will be shadowed by one, it is called many one relation. Finally, many relations is x set and y set, say 1 2 3 3 4 1 3 1 4 2 3 3 4. So, it is called many relation. Many relation is both one many relation and many one relation. So, it is one many relations because one is related to 3 4. So, it is one many relations. It is again many one relations because 1 2 3 are related to 4. So, this is called many relations. So, these are the different types of relations, that is one many one and many relations. So, this is all about relations. So, we have a relation between two non-empty sets are subsets of its Cartesian product. The total number of relations from x to y is 2 to the power x cross y cardinality, and the largest relations is called the universal relation, that is x cross y, and the smallest relations is called empty relations. Next, we have domain and range. So, here the elements of first x sets which are related to y are called domain, and elements of y which are related are called range. So, we have domain and range. Next, we have inverse relations. If R is a relations from x to y, R inverse is a relations from y to x. Then we have finally the types of relations, that is one many one and many relations. So, this is all about relations. Next, we will discuss some special type of relations. Suppose we take another example, that is x set is 1 2 3, y set is 3 4. Then obviously x cross y has 6 element, that is 1 3 1 4 2 3 2 4 3 3 3 4. So, this is x cross y Cartesian. Say we take an example of a relations, a pictorial representation, x set to y set 1 2 3 3 4. Say 1 3 2 3 R 1, this is a relation. Another example, R 2. So, we take three example of relations, three relations. Now, what will be the total number of relations from x to a? So, here the total number of relations here from x to y is equal to 2 to the power x cross y cardinality. So, here it is 2 to the power 6, that is equal to 64. So, out of 64 we consider only 3 examples. Now, out of these 3 examples we will say R1, R2 and R3 are relations. Obviously, there will be total number of 64 relations, but out of these only relation R2 is a function. So, we will come across a special type of relations which is called as a function. So, all relations are not functions. So, obviously, all relations are not functions, but all functions are relations. So, we come to a special type of relations that is called as a function. So, what is a function? So, a special type of relations is called a function. So, we say, so function is a special type of relation. So, in mathematics, if we say it is a special type of relations. So, what is a special type of relations? So, we restrict two conditions. A relation is a function. So, it must satisfy two conditions. The first condition is it is not one many relation. First of all, it should not be one many relations. Second condition, domain must be equal to x set. So, a relation is a function, it must satisfy these two conditions. First condition is it is not one many relations, first condition, and domain should be equal to x set. So, we will say that suppose the same example x set is 1 2 3 and y set is 3 4. So, if we represent pictorially x to y 1 2 3 3 4, here it is 1 3 1 4. Suppose this is a type of relations R 1. Say now, does it is a function? Obviously, the answer is no, because it is one many relation. So, it is not a function. So, one many relation is not a function. Next, suppose x to y 1 2 3 3 4. Say this is R 2. Now, it is one, it is not one many relations, it is many one relations. Now, whether it is a function? Obviously, the answer is no, because here domain of R 2 is equal to 1 2, which is not equal to x set. So, first condition, it must be one, not be one many relations. Second condition, domain should be equal to x set. So, this is not a function. So, relation R 1 is not a function, relation R 2 is not a function, R 1 is not a function, because here it is one many relations, one many relation is not a function. Now, we take one more example, x to y. Obviously, relation R 3 is a function. So, this relation is function because it satisfies both the conditions. So, as it is many one relation and domain of R 3 is equal to x set. So, relation R 3 is a function. So, obviously, all functions are relations, but all relations are not functions. So, what will be the total number of functions from x to y? So, we have total number of relations from x to y is equal to 2 to the power x cross y cardinality, and the total number of functions from x to y is equal to y to the power x. So, this is the total number of functions from x to y. So, if we have say x set has 3 elements, that is a, b, c, and y set has 4 elements c, d, e, f. So, what will be the total number of relations from x to y? So, total number of relations from x to y is equal to 2 to the power x cross y cardinality. So, here it is equal to 2 to the power 12. that is equal to 4096. So, there is a huge number of relations, and the total number of functions from x to y is equal to y to the power x, that is 4 to the power 3, that is 64. So, only 64 out of these 4096 relations are functions. So, that means all functions are relations, but all relations are not functions. So, that means this 64 are included in between these 4096. So, out of the 4096 only very few are functions. So, the relations which is function, it must satisfy these two conditions. First condition is it is must not be one many relation, and second condition is domain should be equal to x set. So, what is the main importance in mathematics? A function. So, how we define a function? So, we define a function. So, function is a relation, it is a special type of relations. So, it is nothing different from relations, only if a relation satisfies some specific conditions, then it is called a function. So, function f from x set to y set, we represent f is a function from x to y. So, another name of function is called mapping. Or transform. So, what is a function in mathematics? Is a function from x to y if every element of x is related to a unique element of y. So, this is the definition of function, that is f is a function from x to y if every element of x. So, what is every element of x? That means it is not one many relation. Every element means it is domain should be x set. Unique element of y means it is not one many relation. So, every element of x means domain should be equal to x set. To a unique element of y, it must be not be one many relations. So, we can take one more example. So, what is the definition in a? Suppose x and y are two sets. X is the set of persons, say passengers. and y is the stoppages. We take one more example. Suppose there are 50 passengers and say there are 5 stoppages. If that is a vehicle, say bus. So, what the vehicle does? It transforms passengers to different stoppages. So, vehicle, that is bus, transform passengers to different stoppages, that is their destinations. So, you can think about this. So, obviously, a passenger cannot drop more than one stoppages. जड़े पैसेंजर एक रु अधिक स्टॉपेज रे ओह्लैबनी. But 2 or 3 stop passengers, 2-3 जन गोटे स्टॉपेज रे. Another thing is, all the passengers will have different destinations. So, this they will go to different places. Some stoppages will not be occupied. So, here domains is always equal to x set, and it is not one many relation, it is many one relations. So, function is just like a transform. It transform. In mathematics we have a vehicle that is called a function. So, this is just like a vehicle. So, it transform a set x to set y. So, it is a very powerful tool in mathematics. So, in all the different parts we have this function. So, function is called a mapping or a transformation that transform x set to y set. So, we have next few examples. Then obviously, domain of function is always equal to x set. If domain is not equal to x set, then obviously it is not a function, it is a relation. So, domain is always equal to x set, and range is subset or y set. So, domain is equal to x set and range is equal to y set. So, you have a function is a transformation or a mapping which transform all elements of x set to a unique element of y set. So, we have domain and range of a function. So, we can take one example, that is a function, say x set is equal to 1, 2, 3, y set is equal to 2, 3. So, now this is a function. So, obviously, domain is equal to x set. Now, what is the range? And range of this function is equal to 2. So, in case of a relations, domain may or may not be exact, but in case of function domain is always equal to exact, and range here it is equal to 2. So, it is many one relations and domain is equal to exact. So, it is a function. Next, we will define, say f is a function from x to y. Suppose here an element is x and f transform x to y. So, we say y is equal to f of x. So, it is read as f of x. So, y is equal to f of x and y is called image of x. So, it is called image because if you have a mirror, then y will be the image of x, and x is called pre-image of y. So, we have image and pre-image. So, y is called image of x and x is called pre-image of y. So, we will take only one more example. Suppose that is x set is equal to and y set. Suppose this is A, B, C, 2, 3. So, f is a function from x to y. Now, f of A is equal to 2, f of B is equal to 2, f of C is equal to 3. So, we have image of A and B are 2 and image of C is 3. Similarly, pre-image of 2 is A and B and pre-image of 3 is C. So, we have function, its domain and range, then we have image and pre-image.